So, hello everyone. My name is Thomas Sandel, and I'm a gastroenterologist and a hepatologist working at the University Hospital in Aarhus, Denmark. So, it's a small country of 6 million people. We're located on top of Germany, and we take care in our hospital, which you can see here on the right. We take care of all Wilson disease patients in Denmark. But it's only 6 million inhabitants, so we have a population of about 50 Wilson disease patients. So I'm very happy to be here today to talk about the use of copper PET in Wilson disease. I'll walk you through that in the next 15 minutes or more or less. So these are my disclosures. So what is PET or positron emission tomography? Well, in this technique or technology, we really use the radioactive or use different radioactive materials to trace what happens to different elements, and any radioactive material that will emit a positron, we can trace that. And it's used for multiple different things in medicine today, the most frequent one being actually sugar PET or glucose PET, which is used to detect different types of infections or cancers. But what we use, of course, is copper PET. We'll return to that. What happens is you inject or ingest a radioactive material. This material must be a positron emitter, being positron emission tomography. What happens to the positron? It meets its counterpart, the electron, and these are each other's antiparticles. And when they meet, if you think back on your high school physics, these two elementary particles will actually annihilate and send out a photon signal. And that photon signal we can detect, and we can actually very precisely localize. And that's the technology we really harness here. So any radioactive signal that can produce a positron can be used in a PET machine. And so again, copper 64 is the copper or the tracer we use here in Wilson disease. And that's of course because it's just copper, but it's a radioactive version. And it emits a positron. It has a half-life of about 12.7 hours, making it very ideal for medium to long-term studies on Wilson disease copper metabolism. We can go to about 65 hours with this. So this is not a months and years study. It's a medium time frame copper investigation, but it's ideal for these for investigating these types of things that I will come back to a bit later. The machine looks something like this, and for any of you who've been into a CT or MRI, this is very, very familiar. And what we get out of it is, first of all, the PET signal, which is the actual section of where the copper is. And here you can see a lot of copper going to the liver and also the intestine. And then we typically fuse it with an anatomical image that could be either a CT or an MRI. And when you fuse those two images, you get something very beautiful like this, and you can see, oh, this is where the copper is going. And one thing is, you can see where it is. You can actually also quantify how much is where. You can furthermore follow it over time, so you can see, well, now it's in the liver, now it's in the bile, now it's in the kidneys, or wherever it goes. So this gives you both the quantification and the resolution time-wise to see what's happening, making it very ideal for copper metabolism investigations. So today I'm going to talk about three possible projects we use. One is to diagnose Wilson disease using PET. The second is the evaluation of different treatments by PET. And finally, the testing of new drugs. I will not mention, in interest of time, the use of PET in animals, but we do investigate both rats and rodents and also larger animals like pigs, and that has, of course, its advantages. But that's for another day. So first of all, diagnosing Wilson disease using PET. So this is a pure PET signal of a healthy volunteer. You can see 2 hours after an IV injection of copper, most of the copper has gone to the liver. We can see also a very nice little black spot here indicating exactly where the gallbladder is. And that, of course, is a proof of biliary excretion. And further, if you look at 18 hours after injection, you can see not only copper in the liver, but you can also see and the colon being quite visible here, indicating again hepatobiliary excretion into the small intestine. So that's exactly what Wilson patients can't do, and in line with this, after 2 hours, you see a lot of copper in the liver in a Wilson patient, nothing in a gallbladder. And looking at 18 hours again, just more copper in the liver. You can see a small shadow here in the small intestine, but this is actually just copper brought directly by blood to the to the small intestine, and not an indication of excretion. So if you measure this, almost all the copper goes directly to the liver. So by this, we can actually diagnose Wilson disease. And of course, this will not be something you use for your everyday clinics. You will still rely on the current methodologies, including investigation of your genes. But for very specific cases, for instance, we have now a young girl flying over to us from London. She has 2 pathogenic mutations, but other than that, no indication of Wilson disease at all. And she has been on therapy since she was 3. So should she continue or not on this therapy? And that's, I think, if we can prove she has copper excretion by this method, we can take her off treatment. And that would really be a way forward for her. So it's in these kinds of rare cases that this is really an interesting tool. So moving on to the second type of project I would like to talk to you about, namely the investigation of existing treatments by PET-CT, and we have here zinc as our investigation. So the research question we asked, and this was actually done by my PhD student Emily, is zinc therapy 150 milligrams times 1 daily as efficient as the standard of care, and that is 50 milligrams 3 times daily. And this is, of course, in the interest of the patient. Could you just collect all the pills in the morning, and that would be just as efficient? So that was the first research question, and the second was, is zinc gluconate as effective as zinc acetate? And so these questions we put into one study, and we tried to answer them by PET-CT. And the way we designed it was that we gave the patients an orange juice containing copper 64. So this was a very expensive orange juice. And then we, after 13 hours, measured how much had been absorbed from the small intestine and had gone to the liver. So this was done baseline. And then after 4 weeks of oral zinc treatment, we did it all again. So orange juice, and then measured how much copper had gone to the liver. And the idea, of course, being that the way zinc works is it blocks copper absorption. So we should see less copper in the liver after 4 weeks of zinc treatment. And for this study, we used healthy subjects because in Wilson disease, the copper absorption is not impaired. It's the excretion by ATP7B that's impaired. So we could either use Wilson or healthy subjects for the study. It really doesn't matter. So much easier for us to use healthy subjects. So we divided the study into these 4 groups: zinc acetate 50 milligrams 3 times daily, zinc acetate 150 milligrams 1 time daily, zinc gluconate 50 milligrams 3 times daily, or zinc gluconate 150 milligrams 1 times daily. And then we did a scan before and after 4 weeks of treatment. And let me guide your attention to this image on the right. This is a before and after PET image of the liver, and you can see a lot less copper here. You see that by the different colors, a lot less copper going to the liver after treatment. And we saw a median reduction of about 50% in the first 3 groups. The only one that really stood out as not as efficient was singluconate 1 times daily. But the other 3 groups had a very comparable and very comparable efficiency in reducing hepatic copper uptake. So on its own, this indicates that zinc acetate 3 times daily is just as efficient as zinc acetate 1 times daily, or as singluconate 3 times daily. And this is, of course, very interesting, but has to be viewed in context of the other available zinc literature out there, and there's quite a lot. So please talk to your doctor before you switch your therapy. What was also interesting for us was the quite variable effect we saw in the patients, some having very, very, very profound effect of zinc therapy and some not. And some of this is due to variability within the study, and others is probably also due to different efficacy of zinc for that specific patient. This has actually also been published in previous studies, so food for thought here. But talk to your doctor before you do anything. And the third possible project I will talk to you about was the testing of new drugs, and I will use terothiamolybdate, also known as Alexion 1840, to some of you. And I'm sure some of you have been on this drug. And my PhD student, Frederick, did the work here. So at the time, we started conducting these studies in collaboration with Alexion Therapeutics. It was a promising experimental copper chelator for use in Wilson disease treatment. It appeared to have a different mode of action to depend on trientine, but the precise action of TTM was unknown at this time, and still is to some extent. So what was available in the literature at the time from in vitro studies and also from animal studies was that we knew that copper would find TTM, that would again find albumin, and together these 3 compounds would form the so-called tripartite complex with TTM, copper, and albumin. And there was a study from Japan in rats showing that then this tripartite complex would actually be excreted into bile. And so this was kind of ideal for us to see if we can show biliary excretion in humans. And so we gave Wilson disease patients IV copper before and after TTM treatment. What we first saw was actually looking at blood, a retention of copper in the bloodstream. You can see here, you can see the vessels in the arms. You can see the heart. After treatment, and this is not visible before treatment. And this is the graph of what it looks like. So this fits completely with the idea of the tripartite complex. It's absorbed differently than copper alone. So just an indication that something has gone on very efficiently with the copper at this time. And then we really wanted to look at hepatobiliary excretion. And so what we saw here was a lot of copper in the liver, some in the kidneys, but to our surprise, we couldn't see anything in the gallbladder. And this was also the case for the small intestine and the colon. We could not see any sign of copper excretion by TTM in Wilson disease patients. And so this was a surprise to us. And what we then looked at was, what about copper absorption? Could TTM have an effect comparable to that of zinc, where it would bind copper in the small intestine? So we gave healthy volunteers TTM treatment and then gave them oral copper before and after, just like the design you saw before with the zinc patient or zinc study. And as you can see here, this was a very, very powerful copper signal before treatment, and the liver is then after TTM completely void of copper. And looking at it more quantitatively here, we can then confirm that TTM has a very, very powerful impact on hepatic copper absorption. And then secondarily, this is probably due to an impaired intestinal copper absorption. So we believe that this is one of the ways that TTM actually works. And that was, to us, of course, very interesting. So let me summarize for TTM. TTM did not increase hepatobiliary copper excretion as measured by copper-64 activity in the gallbladder. Copper was retained in the bloodstream after TTM treatment, and this was in line with our theories about the tripartite complex formation. It is unclear if and how the TTM copper complex leaves the body, but we can say that TTM strongly and significantly reduces hepatic copper-64 activity, indicating a very effective inhibition of copper uptake from the intestine. So in conclusion, ladies and gentlemen, I hope I have shown you that copper-64 PET is a very versatile tool in the investigation of Wilson disease. It sets new standards for drug investigation, and it can help aid in diagnosis and in drug development in Wilson disease. So thank you so much, and I'll be happy to take questions.
Hello, everyone. This is live. So there's a few questions here that I'd like to answer. So one of them is this PET similar to radioactive copper that was used for Wilson diagnosis back in the 60s? So the radioactive copper in the 60s was typically the same as what we use now. They also used radio copper 67. We use 64. They're a bit different, but the principle is completely the same. And what's new here is the much more in-depth spatial and anatomical information you can get. Back in the 60s, you could only get a blood sample, for instance, and measure the radioactivity in that, or in a very broad area across the body, you could measure radioactivity in that area. With this PET technology, as I've shown you in the pictures, you can very specifically and clearly see where the copper is at a certain time point, and you can follow it where it goes afterwards. So in principle, it's the same as it's an add-on to the technique that was developed in the 60s, but now with a much more, it's like playing in a very new stereo compared to what you did for many years ago. So that was the first question. The second one here is, would the PET scan show copper in different areas if the Wilson disease patient had more neurological symptoms and no liver symptoms? So bear in mind that this technique only has a half-life or the copper only has a half-life of 65 hours, 12.7 hours, and that means we can detect it for about 65 hours. So we only have this really short time span to look at. And for neurology, we don't see a difference at this within this short time frame. So no, this will be the same for both neurological patients and for liver patients. So moving on to the next question. Is there any difference with using zinc sulfate rather than gluconate or acetate? Well, in theory, they are comparable. Only one have been, at least in Europe, approved by the EMA, but we still use some of the other compounds in the clinic. There is a difference in side effect profile for sure, but in theory, it should be equally efficient. But there's a lot of other stuff going on here, so you should definitely talk to your doctor before you change therapy. So as a zinc user, we're attempting to want to take zinc acetate 150 milligrams once daily based on your study in healthy volunteers. What kind of study would be needed to confirm an easier dose regimen, trying to caution against people making changes based on a small study with healthy volunteers? I completely agree. And that's also what I said in the presentation. So this is a study that adds on to the existing knowledge we have, and you should always carefully talk to your doctor about your options. So, but I think this is something you could take into consideration when talking to your physicist. So for compliance in zinc regimens, do you recommend once daily versus twice daily? So a bit on the same line here. I will not, in this talk, recommend anything specific. I would recommend you talk to your physician about it. But this is, again, knowledge that adds on to what we have in the first place. On to the next question. Will this technique be available in the clinics in the US? So that's a good question. I don't know. There's, in practice, nothing that will hinder the use. We haven't patented or anything like that. We cannot. So it's free for any hospital to take up this technique and use it. And as a matter of fact, we've encouraged it, of course, because we want to spread this technique. But there's a lot of hindrance in terms of bureaucratic paperwork and so on that needs to be done for each site before they can use a new radioactive compound. So that's at least what scares some clinics away from using this method. Are there any hospitals in the US using PET scans for the diagnosis and guiding treatment? That's another question. So to my knowledge, there's not. I know that some radioactive studies have been done. I think it's in Michigan, but I'm not sure if they use the PET there, but you'd have to ask them directly. So to my knowledge, there's no one who does it in the States at this time. What is the half-life of copper-64? So that's 12.7 hours. So both biologically and physically. Could decay prevent detection of elimination? So yes, that's a good question. Of course, since we only work within this time frame, you have typically about 5 half-lives, and that means 12 hours times 5, where you can detect the radioactive copper, and anything that happens with the copper afterwards, we can't detect it. So if elimination of some compound or drug or whatever we're testing, if that happens afterwards, then we cannot test it using this technique. So you have to be aware of the limitations of PET when you use it. So that was a good question. So moving on to the next one, have you used PET to distinguish between symptomatic and unsymptomatic carriers? No. So we've used it for special cases of diagnosis of patients to distinguish whether they were carriers or not, because as you know, then the genetics of Wilson disease is not easy. So we have a lot of variants that are of unknown significance, and in that light, sometimes we can, as physicians, be in doubt whether or not this patient is actually a true carrier or a true patient, or what happens. So I think for those very special cases, PET might be interesting, but normally we could rely on the, so to speak, normal diagnostic workup we have, and that is typically more than enough. So this is really for the special cases. So what did you learn about mode of action of metanobactin with copper-64? So metanobactin is a compound under investigation at this time point. We have, along with other groups, published papers where we looked at rats, where we gave them metanobactin, and looking with PET, we could see that there was actually a clear excretion via bile to the gut using metanobactin. So that was really something we learned from the PET studies, or actually that we confirmed, because they had some studies in the rats already that indicated this was the case, and we could really nicely show it with the PET studies that this was indeed the case, at least in a rat model of Wilson disease. So this has not been done in humans, I must stress, at this time point. So what is the half-life of zinc gluconate? I can't remember at this point, so sorry about that. So I think that was the final question here. So unless anything else is coming up, I'd like to say thank you for your attention.